Okay, well this is the last video for Math 95, and in this one we're going to talk about adding rational expressions. And remember, rational expressions is just another word or another term for algebraic fractions. So let's talk a little bit about adding fractions, okay? If we want to add whole numbers, it's pretty simplistic. But let's talk about it briefly here for a minute. If we want to add, let's say 3 and 5 together, we can take this piece that's a length of 3, lay it down next to the piece that's a length of 5, and see that this takes us out to 8, right? 1, 2, 3, 4, 5, 6, 7, 8. And that all works out really nicely because our whole numbers are clearly marked on the number line. So the reason why I'm talking about this is because when it comes to fractions, if we want to add two fractions together, things get a little bit tricky. Okay, so let's say we wanted to add 1/2 plus 1/3. So we could do the same thing we did over here, take this little piece that's 1/3 and lay it on the number line next to the 1/2. And there's our answer. That's 1/2 plus 1/3. But the real question is, what do we call that number? Where is it? Where are we on the number line? That's what the process of common denominators allows us to do. We split the halves into thirds. We split the thirds in half. Now they're all sixths. And so this is 3/6, this is 2/6, and the answer that we end up with is 5/6. And something similar happens when we're working with algebraic fractions, is that, we can think of them as a length, but it becomes very difficult to add them together if they don't have the same denominator. So, just like in adding numerical fractions, making a common denominator in adding algebraic fractions is very important. So let's look at some of these. Problem 2, we've got 9 over y plus 8 minus 2 over y. So here's our two denominators. Let's go back to our example, our numerical example, for just a minute. Have a brief refresher about making a common denominator. Okay? And these two denominators are both prime, and so the common denominator is going to be the product of them multiplied together. We're going to multiply this one by 3 over 3. We're going to multiply this one by 2 over 2. And notice that we're multiplying by 1. So we don't change the value of the fraction, we only change its appearance. Okay? And so now this is 3/6, now this is 2/6, and then we can just easily add the numerators together to get 5/6. So we're going to do the same thing over here. These denominators are both prime, so our common denominator is going to be y times y plus 8. And so to create that, this one needs to get multiplied by y over y, and this one gets multiplied by y plus 8 over y plus 8. So here we get 9 times y is 9y, and over here, let's see here, I'll do this as 2 times y plus 8, okay? You can distribute that and call it 2y plus 16 if you want to, but there's something else to watch out for if you end up doing that. So now we'll just put all of our numerators together here, and we've just got that single denominator, y times y plus 8. Now we need to simplify the numerator. 9y minus 2y minus 16. And so in the end, we get 7y minus 16 on top, and y times y plus 8 on the bottom. If you want to call this y squared plus 8y in the denominator, that's fine. That's the same thing. Nothing wrong with that. Okay? All right, so there's the process for number 2. Let's look at some more examples here. Okay, problem 4 is very similar. We've got one denominator that's just a single variable, and then the other denominator is n plus 7. And so we're going to do the same thing. Our common denominator here is the product of these two, n times n plus 7. And over here, we need to multiply by n plus 7 over n plus 7. And over here, we need to multiply by n over n. So here we'll have 5 times n plus 7 plus 4 times n. And then just like we did in the last problem, we want to distribute 5n plus 35 plus 4n. And then combine our like terms. 9n plus 35 over n times n plus 7. Now sometimes people get mixed up and they want to cancel these two right here. But if you remember what I talked about in that last video, how canceling is all about multiplication. Down here, that's fine. These are factors, they can be canceled. This one right here can't be canceled because it's being added. Okay? So that's something to be careful and watch out for. If you feel like you want to cancel something out, think about it a little bit before you do that. Okay? Because I see people make this mistake frequently. They're so excited about canceling something out that they do it in situations where it actually is not, it shouldn't happen. It's not true. Okay. All right, let's keep going with these. Okay, let's see here. Problem 6. We've got y over y minus 5 minus 2 over y plus 5. Okay, well these denominators are a little bit more complicated, but they're both still prime, and so the common denominator is just going to be the two of them multiplied together. Okay, so this one over here needs to get multiplied by y plus 5 over y plus 5. And this one gets multiplied by y minus 5 over y minus 5. So this will be y times y plus 5. And this will be 2 times y minus 5. So in this one, I'll go ahead and multiply these out first before I combine them into a single fraction. And this will be 2y minus 10. Now the reason why I did that is because I want to point something out to you here, which is that this minus sign right here has to get applied to both the 2y and the minus 10. So what we end up with on top is y squared plus 5y minus 2y plus 10. And then we'll combine those like terms in the middle. Y squared plus 3y plus 10 over y minus 5 times y plus 5. And there we go. Okay? So that's the key, is to create this common denominator, multiply in the numerators, and then combine your like terms. Okay, well, what else here? Well, let's look at number 8. We've got 5 over n plus 3 plus 1 over n plus 4. Similar scenario. We've got these two denominators. Our common denominator is going to be the two of them multiplied together. So, This one needs to get multiplied by n plus 4 over n plus 4. And this one gets multiplied by n plus 3 over n plus 3. And again, notice that we're multiplying by 1, right? Anything over itself is equivalent to 1. So we're not changing the value of these fractions, but we do want to change their appearance. So let's see. This will be 5n plus 20. This one is just 1 times n plus 3, so 1n plus 3. And so in the end, we'll get what? 6n plus 23 in the numerator, and n plus 3 times n plus 4 in the denominator. And there we go. Okay, problem 10. We've got 7 over a plus 3 plus 4 over a minus 2. So, same scenario here. Our common denominator is going to be a plus 3 times a minus 2. And this one needs to get multiplied by a minus 2 over a minus 2. And this one gets multiplied by a plus 3 over a plus 3. So this one right here will be 7a minus 14. This one 4a plus 12. Now again, if this was subtraction, you have to be careful about this and make sure you apply it to both of those terms. But it's addition, and so it's not that big a deal. 7a plus 4a is 11a. Negative 14 and positive 12 makes negative 2. And so there's problem 10. Okay, the last two problems on here are a little bit different, and I'll do a numerical example to kind of show a similar problem. So let's take a look at problem 12. This is 6 over x squared minus 16 minus 5 over x plus 4. Okay, so in those other problems I've said a couple times, both the denominators are prime. And that's why we just multiply them together to get a common denominator. Now in this case, this denominator is prime, but this one is factorable. Okay? And this one factors as x plus 4 times x minus 4. So this is going to be our common denominator. Okay? Here's an example of a problem that's similar to this. What if we wanted to add 1/8 plus 1/2? Now, you could just make these into 16ths, right? You could say, oh, this one is 2/16, and this one is 8/16, and that gives us 10/16, which is 5/8. And there's nothing especially wrong with that. Nothing especially wrong with that as long as you reduce this to lowest terms. That's what I was trying to say. Okay, so a similar thing would happen here. If you try to multiply these together, you're going to get a fraction as an answer that's not in lowest terms. Okay, because I always want your answers to be in lowest terms. Here it's a lot easier to reduce than it would be in this problem right here. Okay, so what we do in this situation is leave that one alone, recognize that it's 2 times 4, multiply this by the missing factor, so this will stay 1/8, this will become 4/8, and that takes us directly to our answer in lowest terms, which is 5/8. So that means here we need to multiply by this missing factor over itself. This fraction stays the same, 6 over x squared minus 16. This will be minus 5 times x minus 4. Okay, now they have the same denominator. Let's see, this will be 6 minus 5x plus 20 over x squared minus 16. And so let's see here, this is going to be negative 5x plus 26 over x squared minus 16. There we go. You can call it 26 minus 5x if you want. It's the same thing. Okay, so let's look at the last problem on here. Which one is this? Problem 14. Right, so this one works very similar to the way that number 12 did. Problem 14, we've got 2 over y squared minus y minus 12 plus 5 over y plus 3. Okay, so it's good to know the factors of your denominators. This one is prime, can't be factored. This one factors as y minus 4 times y plus 3. So this is going to be our common denominator, and we'll turn this one into this one by multiplying it by y minus 4 over y minus 4. Okay, so now this one stays the same, 2 over y squared minus y minus 12 plus 5y minus 20 over y squared minus y minus 12. You can write your denominator like this if you want to, y minus 4 times y plus 3. It's the same thing. So the 5y stays the same. This is a positive 2 and a negative 20, so that's going to be minus 18. And I'll write this in factored form. It doesn't matter. Either way, they're both correct. Okay, so this is right, this is right. They're both in lowest terms, and so that's it. Okay, so that's it for our assignments. The next thing that I post will be a sample final exam with me going over the problems, and then next week is finals week. So if you have any questions, be sure to get them cleared up before it comes time for the final. Thanks very much.